Alright class, today we're going to take a look at lesson 2 on absolute value, and that's how absolute value affects the graphs of functions. I'm going to start with a very simple example, the graph of y is equal to the absolute value of x. To graph absolute value functions, you start by graphing the original associated function. In this case, we draw the graph of y equals x. Hopefully you remember from previous courses that y equals absolute value of x is a straight line. It's got a slope of 1 and it's got an x-intercept or a y-intercept of 1. So here we go. I'm going to draw this graph in green. There you have the graph of y is equal to x. Now, one of the things that you'll notice is that on the right hand side here, the y values are positive. For example, when x is equal to 3, the y value is positive 3. That's great. Over here, with an x value of 7, the y value is positive 7. To the left, though, when we have an x value of negative 3, the y value is negative 3. We're interested, remember, in the graph of y equals the absolute value of x. Well, one thing that you know is our y value always is going to be positive. So, here, where our y value is equal to negative 3, to graph the absolute value of negative 3, we need to move up to positive 3. Here, when x is negative 6, the y value is negative 6, but our y values have to be positive, so we move it up to positive 6. Now in red, I'm going to graph this function. So the red graph is y equals the absolute value of x. All right? The shape of y equals the absolute value of x is the same as the shape of y equals x as long as the y values are positive. If the y values become negative, it gets reflected in the x-axis. All right, let's take a look at a second example. It says, consider the absolute value function y equals the absolute value of 3x plus 1. Determine the y-intercept and the x-intercept, sketch the graph, state the domain and range, and express as a piecewise function. Alright, I'm going to start by sketching the graph first with B. That way it's easier for us to see the x-intercept and the y-intercept. So the associated function is y equals 3x plus 1. This is a straight line with a slope of 3 and a y-intercept of 1. So there's our y-intercept. Our slope is 3, which means we rise 3 and run 1. And again, I'm going to draw my associated function in green. And there's the graph of y equals 3x plus 1. Notice that graph heads below the x-axis right here. So this piece of the graph needs to be reflected back up. So let's see if we can find a spot here. That'd be nice. Right there we go. That's negative. It's going to give me a y value of negative 2. It should move up to positive 2. Alright, since this is a straight line, alright, so the orange or the red graph is y equals the absolute value of 3x plus 1. All right, so let's take a look and let's figure out the y-intercept and the x-intercept. All right, notice that the y-intercept of the absolute value of 3x plus 1 is the same as the y-intercept of y equals 3x plus 1. So the y-intercept is 1. Let's see. The x-intercept, which happens when y is equal to 0, figure this out, 0 is equal to 3x plus 1, so negative 1 is equal to 3x, I get x equals negative 1/3. The domain and range. Remember, the domain is going to be all of the x values that we can plug in. And thankfully, the domain of an absolute value function is the same as its associated function. So in this case, the domain is all of the x values such that x is a real number. The range is a subset of the y values. And if you take a look, for the absolute value of 3x plus 1, the smallest y value is 0, and the graph is completely above 0. And the last part of this question says express as a piecewise function. This is where the algebraic definition of the absolute value of a number becomes important. Right? You might remember from last lesson that the absolute value of x is equal to x if x is positive, and negative x if x is negative. Strictly negative. Right? If you take a look above at our original graph, this branch has an equation y equals x. This branch has an equation y equals negative x. So every absolute value function gives you two different pieces to the graph. And that's why it's called a piecewise function. Alright, let's return to y equals the absolute value of 3x plus 1. Alright, so if you notice, our definition is going to change at the x-intercept. Now, to the right of the x-intercept, we have 3x plus 1. When x is bigger than or equal to negative 1/3. We had to switch the sign for the left-hand branch. And so, we'll switch the sign when x is less than negative 1/3. So you can see these are sort of like straight parabolas. They're not parabolas, but they've got a similar property. Alright, they go down, then they go up again. Now in your textbook you might see this written as negative 3x minus 1. Alright, so let me summarize. when you are graphing an absolute value function, you graph the associated original function, and then anywhere that the original function dips below the x-axis, you reflect it above the x-axis. You see the original graph starts to head below the x-axis, so it reflects above the x-axis.